What if I told you Italy is about to build a bridge so massive it will stretch 3.2 kilometers across the Strait of Messina, finally connecting Sicily to the mainland? This is the Messina Bridge, designed to become Europe's longest suspension bridge, a true engineering marvel capable of withstanding some of the most extreme natural forces in the Mediterranean. The project is not just about distance, it's about engineering resilience, with structures built to resist earthquakes, strong winds, and the turbulent currents that have challenged planners for decades. The bridge raises enormous questions. Why is Italy investing billions of euros in a project this complex? How will engineers tackle the challenges of one of Europe's most dangerous maritime environments? And perhaps the biggest question of all, will the Messina Bridge finally create a reliable connection between Sicily and the Italian mainland? Or is it destined to remain Europe's riskiest infrastructure gamble? The answers lie in the bridge's design, history, and the determination of engineers willing to take on one of the continent's boldest construction challenges. For decades, Italy has struggled to provide a reliable connection between Sicily and the mainland, relying largely on ferries that are slow, weather-dependent, and increasingly unable to handle rising traffic volumes. The idea of a bridge across the Messina Strait has been proposed since the 1960s, but financial hurdles, political debates, and technical limitations repeatedly stalled progress. Today, the vision has returned with modern engineering solutions and renewed political commitment, aiming to overcome obstacles that once made the project seem impossible. The Messina Strait itself presents a formidable challenge. This narrow waterway is deep, turbulent, and highly seismic, with winds and currents that can reach dangerous levels during storms. Building a bridge here requires advanced seismic engineering, durable materials, and sophisticated construction techniques. The bridge is not just a transportation solution, it is also an ambitious attempt to reduce travel times, stimulate economic growth in Sicily, and integrate the island more effectively into Italy and Europe's transport networks. If successful, it would transform both regional connectivity and European infrastructure, creating a lasting symbol of engineering audacity. The Messina Bridge is designed to be one of the most ambitious suspension bridges in Europe, combining extreme length with advanced engineering solutions. The total span will be 3.2 kilometers, with a central suspension section of roughly 2 kilometers, making it one of the longest in the world. To support this massive span, the bridge will feature towers rising over 380 meters high, taller than most skyscrapers in Europe, engineered to provide both strength and stability. These towers must anchor the suspension cables while resisting extreme wind pressures and seismic forces common in the Messina Strait region. The bridge will be equipped to handle multi-lane vehicular traffic and high-speed trains, creating a critical transportation artery between Sicily and mainland Italy. Engineers have incorporated state-of-the-art seismic-resistant design, including flexible supports and energy-absorbing structures, allowing the bridge to withstand earthquakes without compromising safety. Wind-resistant technology is another key feature. The bridge's aerodynamic design and tension cables are calculated to reduce vibrations, oscillations, and torsion even in storm-force winds. In addition, the bridge's construction will require cutting-edge materials and advanced building techniques. High-strength steel, corrosion-resistant alloys, and reinforced concrete are being used to ensure longevity in the harsh maritime environment. Every element, from suspension cables to road surfaces, is meticulously engineered to endure decades of heavy traffic, saltwater exposure, and Mediterranean storms. The Messina Bridge is not just a crossing, it is a testament to modern European engineering, pushing the limits of design, material science, and structural resilience. The Messina Bridge is a monumental investment, with costs estimated between 6 and 8 billion euros. Funding comes primarily from the Italian government, supported by European Union infrastructure grants and potential private partnerships. This massive investment reflects the bridge's dual purpose, solving a long-standing transportation bottleneck and stimulating economic growth in Sicily, one of Italy's less developed regions. By connecting the island more efficiently to the mainland, the bridge could unlock trade, tourism, and investment opportunities previously limited by slow ferry crossings. Economically, The bridge is expected to generate thousands of jobs during construction, ranging from engineers and skilled laborers to project managers and support staff. Once operational, it could support logistics, freight transport, and tourism industries by providing a reliable, fast, and safe route for vehicles and trains. Sicilian ports, towns, and industries could see a surge in activity, attracting businesses that were previously deterred by transportation delays. The bridge also represents a long-term investment in European infrastructure. By integrating Sicily more directly into continental transport networks, the Messina Bridge strengthens trade routes, reduces travel times across southern Italy, and positions the island as a strategic hub for Mediterranean commerce. Beyond immediate economic benefits, the project serves as a symbol of national ambition and engineering prowess, demonstrating Italy's ability to undertake mega projects that blend economic development with landmark design. Building the Messina Bridge is one of Europe's most complex engineering undertakings, and the challenges begin with its location. The Messina Strait is a narrow waterway, but it is deceptively difficult. The sea is deep, currents are strong, and the region is highly seismic, with earthquakes historically recorded along this stretch of the Mediterranean. Engineers must ensure that every structural element can withstand tremors, shifting tectonic plates, and the constant motion of water beneath the bridge. Wind is another major obstacle. The strait is notorious for storm-force gusts and turbulent winds, which can cause oscillations and vibrations in long-span bridges. To counter this, the design incorporates aerodynamic bridge decks, tension suspension cables, and tuned mass dampers to absorb and stabilize the structure during storms. Construction crews will also face challenges in erecting the massive 380-meter towers, which must be precisely aligned and secured while suspended over deep waters. Logistics and materials add another layer of difficulty. Transporting millions of tons of steel, concrete, and reinforcement materials to the construction site requires careful planning, especially given Sicily's mountainous terrain and limited port access. Specialized vessels, cranes, and floating platforms will likely be used to assemble massive bridge sections over water. In addition, workers and engineers must operate under strict safety protocols to avoid accidents in an environment where both natural forces and construction scale present serious hazards. Building the Messina Bridge is not just about bridging a gap. It is a battle against nature, distance, and engineering limits, requiring cutting-edge technology, meticulous planning, and relentless precision to make Europe's most ambitious bridge a reality. The Messina Bridge has long been a subject of heated debate in Italy, attracting both support and strong criticism. One of the primary concerns is its enormous cost, estimated between 6 and 8 billion euros. Critics argue that these funds could instead be used for upgrading existing infrastructure, improving regional rail networks, or investing in alternative transportation solutions, such as faster ferries or tunnels, which may offer similar connectivity at lower risk. Environmental concerns are also significant. The construction and presence of the bridge could impact marine ecosystems, local wildlife, and coastal landscapes. Raising alarms among ecologists, the Messina Strait is home to diverse marine life and large-scale construction, including deep-water foundations and heavy maritime traffic, could disrupt habitats and alter the natural environment. Political and bureaucratic hurdles have further fueled controversy. The project has been delayed multiple times over decades, with changing governments, legal disputes, and shifting priorities creating uncertainty. Corruption concerns and fears of cost overruns have also plagued public perception, making some Italians wary of whether the bridge will ever be completed successfully. Despite these criticisms, supporters argue that the long-term benefits outweigh the risks. They emphasize that the bridge would dramatically reduce travel times, boost the Sicilian economy, and serve as a landmark achievement of European engineering. However, the project remains a lightning rod for debate, highlighting the tension between ambition, cost, and environmental responsibility in mega-infrastructure projects. If completed, the Messina Bridge could become one of Europe's most iconic engineering landmarks, setting a new standard for long-span suspension bridges. By directly linking Sicily to the mainland, it will dramatically reduce travel times, allowing vehicles and trains to cross the strait in a fraction of the time compared to ferries. This connectivity could transform Sicily into a strategic economic hub, attracting investment, tourism, and trade that have long been hampered by geographic isolation. The bridge also has the potential to strengthen regional and European transport networks. Faster, more reliable connections between southern Italy and the rest of the continent would facilitate commerce, encourage tourism, and improve access to markets for Sicilian products. Freight transport could become more efficient, reducing reliance on slower, weather-dependent ferry services and streamlining supply chains across the Mediterranean. Beyond economic benefits, the Messina Bridge represents a symbol of national pride and technological achievement. Successfully completing such a challenging project would demonstrate Europe's ability to push engineering limits, combining seismic safety, aerodynamic stability, and modern materials in one of the continent's toughest environments. It could serve as a model for future mega-bridge projects worldwide, inspiring ambitious infrastructure initiatives across earthquake-prone or difficult-to-access regions. The bridge has the potential to reshape transportation, economics, and engineering standards, marking Sicily and southern Italy as centers of connectivity and innovation for decades to come.